Hey friend, Colin here from Sonic Scholar, and welcome to this first video in the playlist where we're talking about string theory. That's a little play on the physics term, but we're talking about immutability in strings today. So just a quick reminder, go ahead and grab this free cheat sheet I've provided for you. You can find the link in the description. It has all the source code that we're going to be covering in this series as well. Let's dive right into it. So let me pull up our code here, and I'm just going to set a breakpoint and we'll just start running into it. So string immutability, what that's really talking about is just the fact that once you create a string, you can't change it. So let's run through the demo here. I've got everything kind of printing out to the console right now. Strings are immutable. Once you create a string, you can't change it. So you can only create a new string and assign it to the same variable, but you may not change the individual characters in a string. Got lots of examples, so let's just look and see here. We've got two strings, S1 and S2. Both are hello and world respectively. You can see the values print out just fine. Now let's just say we want to change S1 to say goodbye instead. So instead of world, so what we're doing is assigning a new string goodbye to S1. Okay, still no shockers yet, but what if we want to change the first character in that string? Well, we can do that, but we just have to remember strings are immutable. So typically you'd have some kind of syntax like this. You know, you'd say S1 of 0 in this array-like syntax. You could get or set the value, but interestingly enough, this string is not an array, right? And so how are we actually able to use this array-like syntax? Do you ever wonder? Well, let's take a look. So before we get into that, let's try to change the first character. If we were to put this in where we have S1 of 0 equals the character G, we get a compiler error, and we can take a look at that just to see. But this is the compiler error you'll get in a property or indexer string.this int cannot be assigned to, it's read only. So just to demo that quickly, go up here, take out my breakpoint, and we'll uncomment this line and quickly see the error, right? Property or index or string this int cannot be assigned to, it's read only. So we'll look in the string class. Let me fire up the demo again. Go ahead and build it. Forgot to comment that line back out. Now we'll go build it. So I've copied a method right out of the string class. Okay, the .NET is open source now, and we can look inside and we have something like this, public char this, and notice some brackets, kind of like that array syntax. Pretty interesting. So what we see is that it's like a property in C#. And so if you're not familiar with properties, we can talk about that later, but a property is kind of like a getter in Java. It has a get method, but there's no set to go with it. And so it returns a character, and the error message we were getting said that it was read only. And that's because there was no set method. So let's keep looking at what we've got here. So we've already seen the string class implements something called an indexer. That's what gives you the special array-like syntax, allows you to access and write data in an array-like fashion. Here's some syntax, just print it out to the console here so you can see it, right? You can think of an indexer as letting you define custom behavior for that array-like bracket operator. So in the above example, I already alluded to this, there's no setter, right? There's only a get. So when we say that a string is immutable, we're saying that the individual characters in the string cannot change because the designers of .NET decided not to make a setter. In fact, if we look further, all the other methods on the string class, every single method is guaranteed to not change any contents of the string. There's other things like to upper, to lower, trim, replace, substring. We'll look at all those in the next videos, but all these methods that seem like they're modifying the string or manipulating them are actually just operating on the original string and returning a new one in the result. So let's look at this, right? Let's pretend we're beginner coders and we can make this really easy but important mistake. Say we want to replace the G in goodbye with a lowercase g. There is a method called string, well, it's replace. And let's see what happens here. So we've called s1.replace, and because the string is immutable, the string is unchanged. Look, s1 still has this uppercase G right here, okay? So that's a common mistake that beginners can make. So what's actually happening here is that the replace method is returning a new string with all instances of uppercase G replaced with the lowercase. So look at this. We've called s1.replace, and we're storing that into s3. It's a new string now. And if we look at the contents of both of those, we see s1 is unmodified. Again, it's immutable. But s3 is a new string with the lowercase g. So that's really it for the immutable demo. There's really not a whole lot more to talk about. Strings are immutable. It just means that the characters inside can't be changed. So if you hear that word, it seems kind of freaky. Don't panic. The reason you might want to care about immutability is for performance. So you can use something called a string builder, which we'll talk about in another video. That is essentially, it's implemented like a mutable version of a string. And for performance reasons, you might want that, but just know that's what string immutability is all about. So if you like this video, hit like, subscribe if you find content like this helpful. And again, don't forget to get your copy of this cheat sheet in the link in the description below. All right, friend, I'll see you in the next video.